Okay, welcome back. Now, here's what I'm going to tell you. Today's lesson is going to seem pretty intimidating, but if you know how to do the last lesson that we did with writing equations, then you're going to do just fine with this. Sometimes these are going to come out with decimals, especially in the lesson today. Now, I made everything on here come out to be a pretty nice, even number, but the steps are going to be the same, and whether it's a decimal or not, it's not going to change anything with the steps, okay? So just remember, if you did the last one, you can do this one. And I'll even try to convince you that this is no harder than the last one. Maybe one teeny, tiny step harder, but yeah. So anyway, let's get started. We're going to be working with scatterplots today. Now, a scatterplot is basically a graph that doesn't form a straight line or a perfect curve. It's not that kind of graph. You can see some examples here, and you can see that the points are, well, they're kind of scattered around this graph. And so that's what a scatterplot is. Now, one of the important concepts to understand with a scatterplot is a trend line, or sometimes they're called a line of best fit or a best fit line. So any variation of those is all kind of talking about the same thing. And then the last concept to really understand with this is correlation, whether something has a positive correlation or no correlation. And correlation just kind of means connection, okay? Positive connection, negative connection. And the ideas of a trend line and a correlation, they're really going to help us understand each other. So let's get started with this. So the first table that we see, or the first graph that we see, is calories burned during exercise. And on the left side, the y-axis we see is calories, and on the x-axis is time. Now, here's the question that I would have for you. Is it possible to draw a line kind of that would fit the data? Now, I know I'm not going to hit every dot, all right? And I'm not going to play connect the dots and go back and forth like that. But as I look at this, those dots generally do form a line that is going something like that. So you see how I kind of drew that line right through the middle of those, about the same number on the top and the bottom, and my line generally fits what's going on with that data, okay? Well, that line that I just drew is called a trend line, okay, or a line of best fit. It's a line that shows the trend of the data, or a line that best fits the data, okay? But that's a trend line. Now, the next question that I'll have is this. Is there a connection in the data? Is there a correlation in the data? And I'm basically asking this question right here. So if you drew a line through it, what kind of slope would that line have? Would it have a positive slope? Would it have a negative slope, or is it just impossible to draw a line through it? Well, that line that we drew had a positive slope, so this first one would have a positive correlation, which means the more time you spend, the more calories you burn. So the more time, the more calories. Let's look at the next one, weightlifting. So on the left side, the y-axis is repetitions. That's how many times you can actually lift a bar. And the one on the bottom, the x-axis, is the weight. So how much weight is on it as you're lifting it. Could I draw a line through these points? Yeah, I sure could. It's not going to touch all of the points, and that's okay. But as I draw this, you can see there's generally about the same number above and below, and that line is definitely following what the trend of the data is. So the next question, is there a correlation? Well, is there a slope to that line that I drew? There sure is. Is it positive or negative? It's negative. It's going down. So this has a negative correlation. Let's look at the bottom one, the library finds. So talk about drawing a trend line through this. Yeah, as I look at that, those dots are just kind of all over the place. So it's not possible for me to draw a trend line or a line of best fit through this. And if I can't draw a line of best fit, that means there's no correlation. There's no connection. Let's look at that graph and see if no connection makes sense. So on the bottom is books borrowed. The x-axis is books borrowed, and the y-axis is fines, okay, like how much you have to pay in library fines. So here's what it says. This is saying that there's no connection between the number of books borrowed and how much of a fine you have to pay. And that would kind of make sense, right? When it comes to library fines, it's not really how many books you borrow that's the big thing, more like your responsibility. That's where the connection is. And so there is no trend line or line of best fit for this library fines, and there's no correlation. There's no connection between that data. Okay, so what if we don't have a graph of it? For this next part, we actually want to take some data out of a scatter plot, and we want to come up with an equation. Now, the reason we do this is because this is really applicable for real life. In real life, not all the times does our data fit on a nice, neat, straight line. A lot of times it's just a little bit varied, like those last pictures that we saw. And if we can figure out the equation of the line of best fit, or the trend line through this, then we can use that equation to make predictions. Okay, let me show you what I mean. So there's some data from a football team, okay, and I'm showing the number of points that they scored. So in the first game, they scored 14 points. In the second, they scored 16. In the third, they scored 25. And then 31 and 33 and 39. Now, if I would plot those on a graph, they would not make a straight line, okay? They just don't. But let's write an equation of this line. So here's what I'm going to do. I'm going to take the smallest point, the point, so that's going to be 1, 14, and the biggest point, 6, 39. Okay, now the game, that would be our x value. The points would be our y value. So I'm going to write these as ordered pairs. So in game 1, this team scored 14 points. In game 6, this team scored 39 points. All right? Let's write an equation for this line. First step, we need to find the slope. So remember, y's go on top, and you know what? I'm going to write it sideways like this so that we can see how this has been, how we've shown this all along. Y's go on top, x's go on the bottom. So we've got 14 and 39 on the top, and on the bottom, 1 and 6. So 14 minus 39, that's going to be negative 25. And on the bottom, 1 minus 6 is negative 5. Negative 25 over negative 5, that's going to be a positive 5. Okay, now let's go back to y equals mx plus b. Our slope, that's our m. That's what we just found, 5. Now come back and use one of those 2 points that we used back here at the beginning. You could choose either one. You can't be wrong, but I think what I'm going to choose is 114. I'm going to choose that point. The numbers are just smaller and they look easier to me. So I'm going to put 1 in for x, 14 in for y. By the way, if I had used the other point, this equation is going to come out the exact same. You don't believe me? Try it. Go back, try it with 6 and 39 and see if we end up with the same equation in the end. So we're going to have 14 equals 5 plus b. Subtract the 5, and that's going to be 9 equals b. So our equation is y equals mx, and the m was 5, mx plus b is 9. 5x plus 9, that's what we did. And again, if you had used the point 639 and sub that in, you're going to end up with the exact same answer. Okay, now let's use this to make a prediction. So this was the team's first 6 games. I want to know how much, let's say they're playing in a sectional championship game. So game 12, how many points are they going to score? So let's make a prediction with this. What that means is we just have to put 12 because it's game 12, and the games were our x's, so we have to put 12 in for x and see what we get. So 5 times 12 is going to be 60, plus 9 is going to be 69 points. So that would mean that this team is going to score 69 points. Now, I don't know if we're going to get there or not. That's an awful lot of points, but that's what our equation is predicting. And if the team keeps improving like they are right now, that's how many they'll score in that sectional championship game. Okay, let's look at the next one. So this is comparing the amount of time you spend studying with the score that you got on a math test. So, for example, a person who spent 1 hour studying got a 76% on the math test. Person who had 2 hours got an 81. 2.5 hours was 79. 4 was 85. The person who spent 4.5 hours got an 86. Person who spent 5 hours got a 92. Now, one thing I want you to notice, all right, in real life, the data doesn't always follow a perfectly straight line. And look at person who studied 2 hours got an 81. Person who studied 2.5 hours got a 79. Sometimes life works out like that, all right? Not always fair. Let's write the equation of this and let's make a prediction. Okay, so we're going to use the first point and the last point. So the first point is 176, and the second point is 592. Let's find the slope first. Y minus y over x minus x. So I've got 76 over 92 on the top. And on the bottom, I've got 1 minus 5. So 76 minus 92 is negative 16. And on the bottom, 1 minus 5 is negative 4. So that's going to be our slope. Our m is going to be a positive 4. Negative 16 divided by negative 4 is positive 4. Let's come back. Y equals mx plus b. So our m is 4. Now come back to either one of these 2 points. I like the first one. It just looks easier to me, but you can't be wrong. You could use 592, but I'm going to use 1 and 76. Okay, so 4 times 1 is 4. So 76 is equal to 4 plus b. Let's subtract that 4 over. And we're going to have 72 is equal to b. So here's what I've got. Y equals 4x, so m times x. We found the m already. We found the b already. mx plus b. Y equals 4x plus 72. Okay, so let's figure this out, okay? Let's use this to make a prediction. Let's say, just for fun, that you spent 8 hours studying, okay? 8 hours studying, what could you expect to get? If you got 8 hours studying, that's our x value is hours. So if we put 8 in for x right there, what are we going to get? Well, 4 times 8 is 32, plus 72 is going to be 104. So I ask you, is this logical that you're going to get 104% on your test if you study for 8 hours? No, it's not. You can't score over 100% on your test. So does this equation work for giving us some good estimates on what your score will be if you study a certain amount of time? Yeah, it is. But it's just a predictor and it's not going to be exactly right. And in this case, the estimate that it gives us for 8 hours is just wrong because we can't score that high. So this one is really, that's not a good predictor for anything. And it turns out anything over 7 hours, this is not going to be a good predictor for. Because at 7 hours, that's when you hit the max of 100. If I put 7 in for x, 4 times 7 is 28, plus 72 is going to be 100. So 7 hours is where we hit our absolute max, and this is just not going to work for anything higher than 7 hours. All right? Okay, so I know that it can be kind of confusing, especially in your homework when you get some decimals in there, but it's all the same. This is just find your slope, sub it in, and solve for b, and then write your final equation. All right? Good luck. I know you've got this.